First of all, there will be a presentation of the team Big Wave with the title Guideline for the Mitigation of Maritime Digital Divide for the Era of Climate Change. Everyone, please welcome Team Big Wave.
안녕하세요. 저는 빅웨이브 팀 팀원 구정은입니다. 이 영상을 찍고 있는 지금 여기는 스위스 제네바입니다. 부득이하게 제가 해외로 인턴십을 급하게 오느라 본선에는 함께 참여를 하지 못하게 되었습니다. 저희 팀의 주제는 기후변화 시대에서의 해운산업에서의 디지털 격차 완화입니다. 저 없이도 남은 두 분이서 모의총회를 잘 이끌어 나가 주실 것이라고 믿고 있습니다. 안녕.
Good morning, fellow delegates and honorables here. Today, we Team Big Wave are here to suggest the guideline for the mitigation of maritime digital divide for the era of climate change. This is our table of contents today. Before we start, let's look around us. From the clothes we are wearing on to the ooze we are stepping on, all of the ocean let them reach us. Over 90% of international goods are transported via shipping industry. The annual record for maritime logistics has excluded 11 billion tons. However, it is also true that this industry is responsible for 3% of global carbon emission, which is contributing to rising temperatures and warmed oceans and extreme climate. These changes threaten the efficiency and even the sustainability of this industry. With the arrival of fourth industrial revolution, some may be able to overcome these challenges of climate change through digital technologies. Yet it is obvious that the accessibility for these technologies is highly limited, and the measurement for these technologies gaps are even lacking. According to Trade Digitalization Index from UNSCOP, while the average digitalization rate of the world is 59%, for Pacific seas like the Solomon Islands, the digitalization rate remained below 30%. Compared with a neighboring country, Australia, the digitalization rate of Solomon Islands is less than 1/3. The calculation of TDI mainly comprise paper-based trade index and cross-border paper-based trade index. That including automated customs systems and electronic payment systems. It is also true that this index is a strong index. However, there is some limitation that it only focusing on the digitalization of trade procedure and not considering the circumstance of each country. These limitations can also be found in current Info's project, Maritime Single Window Program, Smart Sea Project, and e-navigation would be the most prominent examples. While these projects suppose its recipient countries financially and educationally, they often overlook each country's unique economic and environmental circumstance. Here, we pose the need for new indexes that take environmental and social concerns and lead effective mitigation of digital divide. Our first suggestion is maritime technology gap formula to measure the complicated nature of digital divide. Our formula takes 6 key factors into account: maritime trade dependency, the scale of economy, and climate change vulnerability, and maritime accessibility, port infrastructure development, and education and research environment. This distribution ratio for each vectors are as shown in this pie chart. The examination of each vector will take place first, and the score for each vectors will be applied to the ratio later. For instance, let's assume that there we have the basic formula from P1 to P6 shows the distribution rate, and each component shows the contributing factors. The total sum of the ratio would be 100%, and each component will receive a score between 1 and 10. The criteria for the calculation of maritime trade dependency are like this. To calculate maritime trade dependency, we multiply the total GDP in dollars with the container shipping volume and the average shipment value for container from data provided by the World Bank. Liner shipping connectivity index was used as the criteria for port infrastructure development. Because the index considered factors such as the number of direct connection in between ports and the number of regular incoming container ships. The countries are categorized as follows. For the criteria for education and research environment, the government expenditure on education data from the World Bank was used. To improve the quality of this formula, consideration for the rate of female education and budget allocations for maritime specialized education is needed. For the criteria for marine accessibility, coast-right and land area data from the CIA World Factbook was used to measure the maritime accessibility. For landlocked country, we've assigned additional points as concerning the low marine accessibility. To reflect the scale of economy, GDP values were used as criteria. To measure the climate change vulnerability scores from the University of Notre Dame were used as criteria. The impact of climate and ecosystem change on infrastructure such as transportation, communications, and energy is well considered. The final score for each country are like below. While island nations and developing countries receive higher scores, countries with advanced maritime digital technology receive lower scores. For no data with indicator values were missing, data from research newspaper articles or of geographically and culturally similar countries were used for the analysis.
Moreover, we would like to suggest a type for the selection of assistant technologies, which will include the analysis for pragmatic circumstances and the direction of development assistance. The table below classifies the variety of maritime digital divide and needed technology for each recipient country. For instance, for countries significantly lacking for digital port operation, IoT system and intelligent port process may be the most needed technologies. To support sustainable and efficient digital transition of maritime industry, classification of needed technologies and customized support is needed. As the last step of our development cooperation, we suggest standard for the selection of donor countries. Under current systems, donor countries offer financial aid via a trust fund. By involving the responsibilities on carbon emissions and technological development analysis for the consideration, we aim to motivate donor countries to cooperate. The first criteria for the selection of donor countries would be its proportional responsibilities for cumulative carbon emissions. By categorizing countries with its amount of cumulative carbon emissions, countries responsible for greater carbon emissions will also hold more responsibility in supporting recipient countries. The second criteria would be the reduction rate of each donor country's carbon emissions, which will be used in adjusting the consequence of the first criteria. The table below is an example of making appropriate adjustments based on the reduction rate. Countries with more than 5% reduction rate can lower its first consequence one class, and countries with more than 10% reduction rate can lower its first consequences two class. The third criteria is used to divide donor countries into technology support countries and finance support countries. With the number of this third technology pattern, donor countries can be categorized into two ranges, and therefore the assistance can divide it into digital technology transfer and financial support. Here we present the overall step as a schematic diagram. This proposal aligns with SD1's goal 1.2, input on identifying emerging needs of developing countries, in particular SIDS and LDCs to be included in the ITCP. Our formula can present object criteria to identify and select countries in need of capacity building in digital technology. We are here to submit this proposal to the Technical Cooperation Committee, which is responsible for implementing technical cooperation initiatives within the IMO, to utilize it for both ongoing and coming projects. Performance indicators used to figure out the number of programs requiring technical assistance and the number of technical cooperation programs requested by member states, which is PI Index 1.7 and 1.8. Specifically, our index can be used as selection criteria in developing existing projects and expand its recipient and donor countries. For example, the IMO's Maritime Single Window initiative started from the revised FAR Convention, mandates global ports to establish digital systems by exchanging data electronically and processing through a single window. However, due to limitations in technology and funding support, the operation can be seen as ineffective and unprepared. Our proposal can help prioritize countries for cooperation in such projects. Similarly, in Smart City project, it does not consider the effects of climate change. So our index could add various indicators considering the environmental impact index along with existing indicators. Additionally, our proposal can be used as a standard when multi-donor trust funds need new funding or in operation of new projects. With digital technology classification, such as port, navigation, safety, etc. It could also be used in examining the outcome of each project by posing the criteria to be evaluated. Next, we will present the expected result and conclusion. With this proposal, developing countries can expect to trade activation, mitigation of technology gap, technological advancement, and sustainable ocean management. Also, developed countries can expect to reduction in Scope 3 carbon emissions in national supply chain management, fulfill international responsibilities, and prevention of climate crisis acceleration. Each example are presented on this slide. In a nutshell, in order to further develop this proposal, efforts of updating and utilizing direct data are needed. Moreover, understanding the specialty of social factors such as culture and traditions that may harm digital development is not included for our formula. The trials to understand the complex nature of digital divide is now needed. The current acceleration of digitalization is now having a phase of new inequality. Here, we hope our proposal to contribute in promoting technological cooperation and a more equal and environment-friendly future of the arts. And these are our responses. We are Team Big Wave. Thank you for listening.
Thank you very much. Everyone, please give them a big round of applause. Thank you, Team Big Wave. And 2 members worked hard for their member in Geneva. From now on, there will be a Q&A session about this presentation. Let's start with judges. Is there any questions? Yes, please.
Thank you for your interesting presentation. And so with regard to the selected country and score, the page 16, could you show to the page 16? And then as of the government officers to absolutely to considering to the Republic of Korea, what is the situation, what is their score? Maybe I cannot find to the under according to the 16 page. And so how about to the Korea score? Did you have simulated to the with regard to this formula? Can I know that?
Actually, we have to deal with more than 170 countries in once by using some data in one sources like World Bank or some UN chart or that kinds of things. For example, it is really hard to deal in the GDP score in once because some countries has really tiny, small volume of GDP, and even they don't have some data for education expenditure of government, and some countries don't have there some information of container export. So we have to change the criteria and some percent of these components to deal with the real huge enormous data. So we have to change the score for some countries by ourselves to make this formula work. So I think our formula has some clear limitation to deal with score. So maybe this score on this table is not the really exact
Okay, I understand. In terms of the submitting the IMO paper as the government, absolutely, it is important to the what is the situation, what is the score of the Republic of Korea in comparison with the other country, maybe Singapore, Japan, Germany, United States, and United Kingdom. Also, maybe I'm just wondering to our Republic of Korea in this area country, almost same or not, is very important to submit. The IMO paper is submitted by the government, Republic of Korea. That is a very important to the aspect, I think so. Anyway, to the very, very interesting, the formula, I very, very the good listening from the information and formula delivery to me. Thank you.
저는 조금 좀 차원이 다른 질문을 좀 해보겠습니다. 일단 첫 발표가 상당히 중요한데 잘 하셨고요. 지금 이거 가이드라인을 제출한다는 것 자체가 상당히 의미가 있습니다. 우리나라 위상이 디지털 강국으로서, 그다음에 IMO 내에서 상당히 입지를 지금 위상을 갖고 있는 한국으로서 제안할 수 있는 그러한 가치도 있고 의미가 상당히 큰 제안인 듯합니다. 그 리서피언 컨트리와 도너 컨트리를 나누는 포뮬러를 정량적인 걸 제시하는 것도 상당히 좋은데, 그거에 대한 구체적인 테크니컬한 기술 표지나 인디케이터 이거는 보지 않겠어요. 그거는 이제 향후에 진짜 필요하다 그러면 그건 정량화해 나가면 되는데, 그 이전에 이 가이드라인을 제안할 때 많은 회원국들이 같이 공감을 하고 지지 채택을 해줄 수 있는 이러한 요소가 더 중요하다고 봅니다. 그러면 그 모든 이해 당사자들이 이 디지털 그 격차 해소를 통해서 가져갈 수 있는 이익, 베네핏 이런 게 좀 강조가 돼야 되는데, 이 제안이 받아들일 수 있도록 할 수 있는 그러한 어떤 주장이나 이런 건 좀 구체적으로 한번 더 추가 설명을 해봅시죠. 어떤 제안을 했을 때 이것이 받아들여질 수 있겠는가? 그 채택이 되는 게 중요하거든요. 그렇죠? 예.
네, 일단
Excuse me, our competition is going to conduct it in English, yes.
And the reason why we make the formula of recipient countries and donor country is to make the continuous relationship between donor countries and recipient countries, so that we can transfer the technology or fund assistance via the. It is not to just one time, and make the continuous relationship so that the actual transfer technology can be accelerated in the digital maritime industry. And I think the formula of recipient countries can make the transparent open data, so that everyone can the acknowledge its consequences, and the donor countries can make the it's like the company ESG scope 3 company that consider the national supply chain. So it is important to recipient countries to reduce carbon emissions also in the recipient countries in the national supply chain. So it is the important reason for submitting this proposal to IMO.
Okay, thank you so much for your answers. I didn't know that I have to speak in English. So anyway, your point is very important, but I think you need to emphasize some more points. For example, through this kind of guidelines, we can increase some kind of the public happiness at the seaside, because the recipient country, if they introduce this kind of technology into their sea areas, they can increase the public happiness for their people. And also, not only to emphasize of the responsibilities of the donor countries, you can propose some kind of incentive methods for the donor country by increasing their donor to the recipient country to develop their digital technology around their sea areas. Such kind of thing is very important to persuade the other member states to participate, or not only the member states but also the other some organization, like as you told during your presentation, the World Bank, or in the Asian countries for the Asian Development Bank, such kind of donor organization is very important to have some role to support financially. Thank you so much.
Thank you.
Thank you so much. And are there any questions on the floor? Okay, Team One Piece, please.
Okay, thank you for your wonderful presentation. In slide 19 of your presentation, you mentioned that major carbon-emitting countries will be asked for fund assistance or technology assistance, right? However, from an environmental ethics perspective, isn't there a concern that this approach, rather than being a direct solution like actual CO2 reduction, could be interpreted as an attempt by these countries to evade their environment responsibilities.
The actual reason why we select the CO2 emissions in the reduction rate is because there is need to consider about the responsibilities on the carbon emissions, and also with the compensation and the reduction rate. It is very hard to comply with the 2050 neutral carbon scenario. Is very important, but it is very hard to realization of the scenario. So every country is making the decision, but we thought that in the international cooperation, the considering of carbon emissions is also important.
Okay, thank you. I love to spend more time on this Q&A, but time is up, so we have to wrap it up here. Everyone, please give them a big round of applause.